Good morning. It is March 16th, 2020. It's day 3 of remote learning. And some people were asking questions about having a chemical equation along with a delta H. So I wanted to talk about that a bit. So here's the equation. This is example 8.4 in your textbook. And that's the equation. Really simple. We've got only one coefficient. We've got a 2 on the product side, but the other coefficients are just 1. So that's what everybody's used to. No problem with that. We can convert from mass to moles and moles to molecules, and you can do that. But now we're throwing in this delta H. Okay, so we have a delta H. We see that it's negative. That's important. And we see a value of 185 kilojoules. So just talk about a few points here. Number one, the sign is going to tell you if a reaction is endothermic or exothermic. So this is negative, so it's exothermic. That means when these things combine, or when their bonds break and these new bonds form, energy is given off. Energy comes out of that system. So we would expect that whatever was around it, including the atoms themselves, we'd expect them to heat up. We'd expect the temperature to go up. So might not always be the case, but usually. So that's the sign. So make sure you get the sign. The thing is, if we actually reverse this equation, I have that down here, but if we reverse this equation, we just reverse the sign. Instead of being negative, we would make that positive. So that's how you manipulate these delta H's when you do something different with an equation. Next thing, the number. So this number, this 185 kilojoules, that is connected to each coefficient that you see in the equation. We've got 1s on the reactant side, we've got a 2 on the product side. So if 1 mole of hydrogen reacts, negative 185 kilojoules, 185 kilojoules will be released. If 1 mole of chlorine reacts, if 2 moles of hydrogen chloride are formed, 185 kilojoules would be released. And those masses would be different, right? For hydrogen, that would be about 2 grams of hydrogen is 1 mole. For chlorine, it's about 71 grams of chlorine. For hydrogen chloride, is something like 36.5, right? So, by the way, the reason I'm saying hydrogen chloride and not hydrochloric acid is that this is not dissolved in water, right? HCl is a gas. We don't really call it an acid unless we put it in water. This is the distinction. Now, next thing, so yeah, if you reverse the equation, you reverse the sign. If you multiply the coefficients by a factor, right? Like if you're ever asked something and they said, oh, you now have, instead of these coefficients, we're going to go ahead and we're going to write an equation and change it. So maybe we do like a 2, and a 4. 2, 2, and 4 is still balanced. But if it was 2 and 2 and 4, we've doubled all of the coefficients so that delta H should also double, right? Because the equation is talking about twice as much H2. That's all. If we go ahead and we cut the equation in half, then let's say we started back at our original. We had H2 and Cl2, and we did 1/2 and 1/2 and 1. Right? Well, 1 mole of HCl does not release 185 kilojoules when it is formed. It produces half of that amount. Okay, so any time you do something to the coefficients, do the same thing to that number. That's it for 8.4. I think that explanation applies to 8.6 as well. 8.6, they're asking you to kind of change reverse some equations, and then you need to flip the sign. You multiply by -1, and then if you do something like this, there you go.